Hello everyone, my name is Nurin Kamalia binti Shamsul Kamar. My metric number is 200441. This is PHY3104 Electromagnetism. In this video, we're gonna solve a question from tutorial 6. Question number 9. Question number 9 says, concentric shells R equal to 20 cm and R equal to 30 cm are held at V equal to 0 and V equal to 50, respectively. If the space between them is filled with dielectric material, permittivity equal to 3.1 permittivity naught and sigma equal to 10 power of negative 12, find A, V, E, and D, B, the charge densities on the shells, and C, the leakage resistance. For question A, we need to find V, E, and D. Find V first. We know the basic formula is delta squared V equal to 0. They give us R, which means we need to use the R, which is 1 over R squared D over dr R squared dV over dr equal to 0. From this equation, we can find the V, the equation for V. So, D over dr R squared zero max, we will be left with equal to A. Then dV over dr, we will get A over R squared. And lastly, V, we will get negative A over R plus B. In order to find equation V, we need to find the value for A and B. So we can find the value for A and B based on the info that they give in the question. We need to find the value of A. They give us R equal to 20 cm, then V equal to 0 volt. If R equal to 30 cm, then V equal to 50 volt. We can get the value of A and B from this equation. So we will solve for the R equal to 20 cm first. We put it into this equation. 0 equal to negative A over 0.2 plus B. From here, we can derive, and we will get B equal to A 0.2. So we get that B equal to A over 0.2. We don't know the value of A, so we go to this one. 50 equal to negative A over 0.3 plus B. We know that B equal to A over 0.2. So A 0.2. From this equation, we solve it and we will get 5 over 3 A. At the end, we will get A equal to 30. So we can find the value for B. Bring this A into here. 30 over 0.2. Then we will get B equal to 150. Now we find the V. V equal to negative 30 over R plus 150. So this is the answer for V. For E, we know the basic equation for E. We use negative delta V. It will be negative T over TR. We put this equation here, so we will get negative 3T over R plus 150 AR. AR. So we solve it. We will get the negative 30 over R squared AR for our meter. D, we use the formula permittivity E. We got this E here, so just put it into the equation. They give us permittivity equal to 3.1. 3.1 permittivity not negative 30 over R squared. We will get negative 93 permittivity not over R squared. Don't forget AR. We will get negative 8.23 over R squared negative 10. I want this answer to be in nano. I will get negative 0.823 over R squared AR nano coulomb per meter squared. Now we solve the first question. First question want us to find V, E and D. So we found V, we found E, and this is D. Now for the question B, they want us to find the charge densities. Note that we have R equal to 30 centimeter and we have R equal to 20 centimeter. The basic equation we're going to use is rho S equal to Dn. Dn, this is actually D A N. I want you to note that AN equals to negative AR. From the previous equation, we know the answer for D is negative 0.823 over R squared AR. So negative 0.823 over R squared AR nano coulomb meter squared. Put the R, which is 0.3, 30 centimeter, negative 0.823 over 0.3 squared. Don't forget squared here, times 10 negative 9. We will get the answer is 9.144 nano coulomb meter squared. For R equal to 20 centimeter, note that AN equal to positive AR. Rho S equal to D, and so we know D is A and negative 0.823 over 0.2 squared times 10 power negative 9. You will get negative 20.58 nano coulomb per meter square. We find the charge densities. For R 30 cm, it's 9.144 nano coulomb per meter squared, and for R 20 cm, negative 20.58 nano coulomb per meter squared. For the last sub question C, we need to find what is the leakage resistance. For this whole question, we know this is spherical. To find the leakage resistance, we will use R equal to 1 over A minus 1 over B over 4 pi sigma. This is where we're gonna use the sigma that they give us in the question. 1 over A is 0.2 minus 1 over B, and B is 0.3 over 4 pi, and the sigma they give us is 10 power of negative 12. The answer 1.326 times 10 power of 11. So I want to change it into giga, so it will be 132.6 times 10 power of 9. Final one is 132.6 giga ohm. This is the leakage resistance for the spherical. That's all on how to answer the question 9. So let's recap back. The question, they give us R equal to 20 centimeter, R equal to 30 centimeter. They give V equal to 0, they give V equal to 50. They also give us the permittivity and sigma. Important key in this question. They want us to find V, E, and D. We know we use this equation, delta squared V equal to 0. As they give us R, so we use the R equation equal to 0, and we will find the general equation for V. We know just now our V is V AR, negative AR plus B. They give us 2R, so in order to find A and B, we use the 2R they give us, which are 20 cm and 30 cm. Simple derivative and substitution equation method. So at the end we will get our V is V equal to negative 30 over R plus 150 V. Next we need to find the E and D. For E, we use E equal to negative delta of V, and D we use D permittivity E. If you did not find V, you cannot answer E. If you did not find E, you cannot answer the D. As you can see, the question is related to each other. So in the end, you will get E negative 30 over R squared, you get this, and you get the D. So for the question B, they want us to find the charge densities. So we use this equation. Dn is D An, and An equals to negative AR. So we need to find the charge densities for 2R they give us. For the question C, they want us to find the leakage resistance for spherical. We use the R equal to 1 over A minus 1 over B. A equal to 0.2 and B equal to 0.3. Don't forget sigma. So the answer, you get it, 132.6 giga ohm. I think that's all on how to answer the question 9 from tutorial 6. I hope you understand. Thank you.